The type of the reaction for organometallic reagents depend on the actual carbon ion that you are starting with. So if you're starting with an alkyl, lithium, or a Grignard, those two are very reactive carbon ions. And these carbon ions can do double job, can act as a base or they can act as a nucleophile. If they act as a base, then you're going to have an acid-base reaction. And if they act as a nucleophile, then you're going to end up having a nucleophile electrophile reaction. It's always the acid-base reaction has a priority if there is any acidic hydrogen in the solution. If there's no acidic hydrogen, then you're going to end up having a nucleophile electrophile reaction where your carbon ion is going to behave as a nucleophile and it will react with any electrophile in the solution. On the other hand, Gilman is less reactive. Gilman can never act as a base. So the R over here, this one can never act as a base. So there is no acid-base reaction for Gilman. For Gilman, the carbon ion only acts as a nucleophile. We have examples of acid-base reactions of alkyl lithium and Grignards. Let's say, for example, if we have this carboxylic acid and we are reacting it with alkyl lithium in there. So we said that always look at the carbon that is connected to the lithium. This is going to be your carb anion in there. This acts as a nucleophile and it acts as a base. It acts as a base whenever you have an acidic hydrogen. And here we have an acidic hydrogen, so it's going to act as a base in there. That acidic hydrogen is connected to the oxygen in there. The reason why it's acidic, this is carboxylic acid. The reason why this hydrogen is acidic because it is connected to an electronegative element. So now the base is going to take that acidic hydrogen because bases always take acidic hydrogens. This is going to be our base now. Okay, base is always our source of electrons. So you're going to start from the base towards the acidic hydrogen. That acidic hydrogen is a partial positive hydrogen in there. And we said that the more electronegative the atom is, the more partial positive the hydrogen is, and the more acidic is the hydrogen. So bases take acidic hydrogens. Always the acid is going to turn into a conjugate base. And the base is going to be a conjugate acid. Plus, in this case, the base is going to be a conjugate acid. So all I'm doing here is that I am making a bond between this carbon and this hydrogen in there. So you will have a hydrogen over here, and that is going to be a conjugate acid. Let's have another example in there. Let's say if we have this terminal alkyne, and we are reacting that terminal alkyne with, let's say, a Grignard in there. So we have a double bond and then the Mg and the Br. Okay, now in this case, again, you always look at the carbon. It doesn't matter. The carbon can be an sp2, an sp, or an sp3 hybridization that is connected to the metal. Here in this case, this is going to be my carb anion. Again, look at your reactant and see if you have any acidic hydrogen, then the acid-base reaction is going to be favored in this case over the nucleophile reaction. And now this is going to act as a base from the lone pair, and this is going to be the acid. I know it's an acid because it's a terminal alkyne and the hydrogen is connected to an sp carbon in there, so that it's acidic enough for the base to come and take it. So the reaction is going to happen as such. The base is going to come, take that acidic hydrogen and break the bond and add the electrons to the carbon. So you will end up getting your conjugate base in this case. Don't forget your lone pairs. This is going to be a negative charge. That negative charge will be balanced with whatever counter ions you have in the solution in there. This is going to be your conjugate base. always acids turn into conjugate bases, plus the base is going to pick up a hydrogen. So all I did is I picked up a hydrogen over here. So you're going to end up having a hydrogen. Pay attention to your number of carbons in there. I have 3 carbons for the R of the Grignard. They are going to remain 3 carbons in there. I'm not doing anything other than adding a hydrogen from the acid to the carbon ion in there, and that is going to be the conjugate acid. The more acidic the hydrogen is depends on the electronegativity of the atom that it is connected to. So if I have something like this, let's say, for example, if I have this here like lithium, in there. So if I am looking at this hydrogen over here, this hydrogen is connected to a chlorine. Chlorine is way more electronegative than the hydrogen. So it's going to pull electrons away from the hydrogen and make it partial positive. So now I have an acid in there. If I want to compare the acidity of the hydrogen connected to a chlorine versus a hydrogen connected to the oxygen, this one is going to be way more acidic because chlorine is more electronegative than the oxygen. The carbon ion over here, this is your base. So that carbon ion now, since I have an acidic hydrogen, it's going to take that acidic hydrogen in there, and the halogen is going to leave. Already the halogen has 3 lone pairs, and you're going to add one more. So your product in this case is going to be a conjugate. There we go. So that is going to be your base. The base is going to turn into a conjugate acid, and the acid is going to turn into a conjugate base. So you're going to end up having your Cl minus. Always bases are negative, okay? So that is going to be your conjugate base in there. Just as a note that the charges and the reactants need to balance the charges and the products. So over here, since I have a 0 charge in the reactants in there, this is 0 because the lithium is positive. Then your products need to be a 0 charge as well. Reaction also can happen with alcohols. If you have an alcohol in there, then this is an acidic hydrogen. Immediately, this is going to be an acid-base reaction. It also can happen with water. I can replace the hydrogen of the water by deuterium. So I can have a DOD in there, and the D is going to act exactly like a hydrogen. So you're going to end up having an acid-base reaction. So if I am reacting this, let's say with that same carbon ion in there, then I'm going to have an acid-base reaction. This is going to come, pick up the D, and the OD is going to leave. So I'm going to end up getting my acid-base reaction in this case, and that is going to be a D, plus the OD is going to be my conjugate base in the solution. It's going to be the conjugate base. This is going to be the acid, and this is going to be my base in there, and that is going to be my acid. It's very important to start your arrow from the source of electrons, which is the carbon ion, towards the electron deficient element. In this case, always it's going to be towards the partial positive in there, and then every time you make a bond, you break a bond. There are more examples in the notes. Please look at these examples.